Okay, let's take a second to talk about reflections. Reflection is just a fancy math word for flip. So if we're talking about the transformation of reflecting something, we are flipping it. So for example, if I reflected this across the x-axis, I would flip it over the x-axis. I would actually flip my figure upside down, and it would end up looking something like that. That's a reflection across the x-axis. I took my figure and I actually flipped it. Now when we do a reflection, it creates this line of reflection. Here it happens to be the x-axis because that's what I reflected it over. And the line of reflection is cool because if you fold your paper along that line, your figures will map onto each other, or they'll lay back on themselves. So let's talk about a couple line of reflections and lines of symmetry. If we check out this butterfly here, pretty butterfly, it does have a line of symmetry right down the middle. And this line of symmetry means that if I take my butterfly and I fold it along that line of symmetry, it's going to map onto itself. In other words, both of the sides, both of the wings are going to exactly line up. All right, so this pretty little butterfly here has a line of symmetry. So if I fold it onto itself, it'll map. If I fold it, it'll map onto itself. Let's go over a couple other lines of symmetry. If we check out this picture of these birds on the water, there's actually two lines of symmetry here. The first one is vertical. I could fold it vertically, and it's kind of hard to see, but those two sides would be exactly the same. They would lie on top of each other. In other words, they would map onto each other. I also have a horizontal line of symmetry, so if I folded it horizontally, again, it's kind of hard to see because I couldn't cut it out all the way, but those two birds map onto each other. In other words, their heads are in the same spot, their bodies are in the same spot. So this has two lines of symmetry, a horizontal and a vertical line. And then let's look at this one. These are two different triangles, but we're still looking for the line of reflection or the line of symmetry. And here, the line of reflection is going to be where you could fold it to where those two triangles would lie on top of each other. And it looks like it's going to be right there. So that is not the x-axis, that's below the x-axis. So the line of reflection here would be at x equals -2 because it crosses the x-axis at -2. Alright, so again, our reflection is just a flip. Let's say that we wanted to start with this original image and we wanted to reflect it across the y-axis. So we want to flip it across the y-axis. So we would take it and we would flip it, and it would end up looking like that. All right, we could reflect across any line of reflection that we wanted to. Let's say that I wanted to reflect across this pencil. I would take my shape and I would just flip it across that pencil, and it would look approximately like that. And the way that you can check to make sure you've done a reflection correctly is, for example, this isn't quite perfect. Okay. You could always double check yourself. To get to the line of reflection here, I went one diagonal space. And so for this to be a correct reflection, I would have to go one diagonal space in the opposite direction. So this one's not exactly perfect, but you can tell, oops, that was a terrible line. So you can tell that I've pretty much got it correct. And if I folded it along this pencil, those two images would map onto themselves. So a reflection is just a flip. If you want to reflect something, you just flip it.